Write the absolute value of x equals the square root of x squared to show that the derivative of the absolute value of x is x over the absolute value of x. First, the derivative of the absolute value of x is the same as the derivative of the square root of x squared. Using the chain rule, the derivative of the square root is 1 over 2 times the square root of the exact expression. This expression is the inner function. And then we multiply the derivative of the inner function, which is the derivative of x squared, or 2x. 2 and 2 canceled out, so we end up with x over the square root of x squared. But remember, by definition, the square root of x squared is the absolute value of x. And so we write this as x over the absolute value of x. We just show that the derivative of the absolute value of x is x over the absolute value of x. Suppose f of x equals the absolute value of sine of x. Find f prime and sketch the graph of f and f prime on the same coordinate axis. Where is f not differentiable? First, we rewrite f of x equals the absolute value of sine of x as the square root of sine squared of x, or sine of x squared. F prime of x is therefore 1 over 2 root. The inner function is sine squared of x, and we multiply the derivative of the inner function. The derivative of sine squared of x is 2 sine of x times cosine of x. Remember that sine squared of x is sine of x, the quantity squared. And so in this case, we use both the power rule and the chain rule. The factor 2 canceled, so we end up with sine of x cosine of x. The square root of sine squared of x is, by definition, the absolute value of sine of x. And so this is plus or minus cosine of x, because the absolute value of sine of x is either positive or negative sine of x, and sine of x canceled out. The graph of f of x is entirely above the x-axis because it is the absolute value, and so normally sine of x would look like this: middle, high, middle, low, middle. But then since the graph is entirely above the x-axis, we have sine of x being entirely above the x-axis. Without the absolute value, sine of x would have been negative at these two intervals, negative pi over 2 to 0 or pi over 2 to pi. Keep in mind that the domain of sine is a set of all real numbers, and so this keep go on forever. We want to keep track of where we take the absolute value of sine of x to obtain the positive, because in these intervals we would end up with the graph of negative cosine of x. From 0 to pi over 2, we would have cosine of x. But from pi over 2 to pi, we would end up with the negative cosine of x, which is now flip. Similarly, from negative pi over 2 to 0, we would end up with the negative cosine of x, and so on. The blue graph is the graph of the derivative. We notice that at negative pi over 2, 0, pi over 2, these are the multiple of pi over 2, 0 included. F is not differentiable because at these points the graph of f has a corner. F is not differentiable at the corner. Find the derivative of g of x equals the absolute value of sine of x. First, we rewrite g of x as sine of the square root of x squared. Again, the definition of the absolute value of x is the square root of x squared. And then we use the chain rule. The sine function outside is cosine, and then we would rewrite the inner function, and then we multiply the derivative of the inner function, which is the derivative of the square root of x squared, or 1 over 2 root x squared, whose inner function is x squared, so we would multiply 2x. We don't have to do this because we found the derivative of the square root of x squared earlier. This is cosine. Remember that the definition of the absolute value is the square root of x squared, so we rewrite it as cosine of the absolute value of x. And then x over the square root of x squared. But again, the square root of x squared is the absolute value of x. No, we won't be able to cancel out this absolute value because in the numerator, the absolute value of x is an argument of cosine, so it is stuck inside cosine. We can simplify this and end up with plus or minus cosine of the absolute value of x. This is the graph of sine of the absolute value of x. Normally, the graph of sine of x would go down here, but because we take the absolute value of x, it would look like the graph of sine of x from 0 to pi. On the graph of f, wherever there is a corner, f is not differentiable, and so the graph of the derivative of f has a gap there. The only place this happens is at x equals 0, and so we would say that the function g of x is not differentiable at x equals 0.